Thank you for watching my video once again. My name is Mr. Charles Winike. In this video tutorial, we will continue from where we stopped initially from our previous video when we are discussing on dielectric. So in this case, this is where we stop, which I mentioned that I say that the amount of polarization which occurs when a certain voltage is applied to an dielectric material or dielectric object, it influences the amount of electrical energy that is stored in the electric field. What I mean by that is that the amount of voltage that is polarized, that is involved, or the amount of polarization which occurs when a certain voltage is applied. That the amount of polarization, if you remember what I spoke about the polarization aspect, which moves from the electron from negative to positive, which can be viewed by microscopic material, which means that the amount, if it is a voltage like 12 volts that move for polarization, it means that is it influences the amount of electrical energy that is stored in the electric field. That is what I mean. If it is 12 volts, 13 volts, and so on and so forth, voltage are different, all depending on what you are doing as of that particular moment. So that is why I say the amount of polarization, which I have already defined polarization in this dielectric material, the amount of polarization which occurs when a certain voltage is applied to an dielectric object, it influences the amount of electrical energy that is stored in the electric field. So we are moving forward to this. Now this is described in a certain definition. There is one particular law that is governed to it. So that is what I'm trying to explain here. This is described by the dielectric constant, of the material. What is telling you what is giving you that particular idea, or telling you that the amount of polarization that occurs and so thing is what is called dielectric constant of the material. The dielectric constant is not the only property of dielectric material, remember, but the dielectric constant is what is telling you exactly what I have just explained here, that the amount of polarization which occurs when a certain voltage is applied to an object, it influences the amount of electrical energy that is stored in the electric field. That is what the dielectric constant is trying to explain here. So in that case, what I want you to know is the dielectric constant is not the only property of dielectric material. There are also other other properties of dielectric material as well. Other properties show as dielectric strength and dielectric loss are equally important in the choice of material for a capacitor in a given application. All these properties are very important in dielectric material as long as capacitor is concerned as well. So in that case, just as I said that we will discuss on dielectric constant, dielectric strength, and dielectric losses. In that area, we'll also discuss dielectric and capacitor. All these things are the materials that makes up of dielectric material and capacitor. So dielectric in capacitor. Dielectric can be of two types. Dielectric can be of two types, which is one is polar dielectrics. Polar dielectric. These dielectrics will have permanent dielectric movement. In polar dielectric, it doesn't the dielectric it doesn't move. It remains permanent. It doesn't move from one state to another. The dielectric of polar, it remains permanent, and wherever you install or you keep the dielectric, that is where it will remain. While the second one is non-polar dielectrics. Non-polar dielectric. This will have temporary dielectric movement. In non-polar dielectric, it has temporary dielectric movement, which means by placing them in electric field, they can be induced with dipole moment, which they can be induced with dipole moment. They are not constant. They are not constant in that dielectric. Not that you'll be moving them, but they are not constant. They can be induced with dipole movement. They can be induced with dipole movement. It's not that that you will remove them and place another. No, there will be a little slight movement, shift from one place to another place. That is why I said this will be temporary dielectric movement. By placing them in that electric field, in that electric field, they can be induced with dipole moment. Dielectric also play an important role in deciding the value of capacitance. This is where it is. Dielectric also play an important role in deciding the value of capacitance. You know, in capacitor, you consider the voltage rating, the capacitance, as well as the temperature. And after that, you also consider the tolerance, you also consider the ripple current, numerous then to be considered if you are to take on capacitor. So in this case, dielectric plays an important role in deciding the value of capacitance of capacitor. As the dielectric is introduced between the plate of the capacitor, its value increases or changes. As dielectric is introduced between the plate of the capacitor, its value, it is either increases or it changes. Changes can be decreases, changes can be increases as well. But in this case, I will also say increases or changes. So what I'm trying to explain here, once the dielectric has been introduced in any of the capacitor, one, the name will change. That is the changes. Depending on the dielectric name that you are going to use. If you are using polarized like electrolytic capacitor, it means that it has a positive and negative terminal, which means that there are so many things to put in consideration. You know, in electrolytic capacitor, the capacitance is as well as high, the voltage rating is also high, all depending on what you want to use it for. So the changes is what I'm trying to explain here. The changes is all depending on the name of the dielectric you are to use in doing your capacitor manufacturing. There are different types and different shapes of capacitors available, from very small. Yeah, there are different types of capacitor and different shapes of capacitor available, from very small capacitor to which are used in resonance circuits to large capacitor for stabilizing high voltage direct current line. Is to stabilize high voltage direct current line. So in that case, capacitor, it also do the same job. So what I'm trying to explain here is this. Capacitor, they are in different form, but they do the same thing all generally. There are different shapes, there are different types and different shapes of capacitors available, from very small capacitor which are used in resonance circuit to large capacitor for stabilizing high voltage direct current line as well. But all capacitors are doing the same work, that is storing the electrical energy. All capacitors are doing the same work, that is storing the electrical energy. The shape of a capacitor is a rectangular. The shape of a capacitor is a rectangular, square, circular, cylinder, or spherical shape. All these are shape of a capacitor. I have given you the image or the, the, the photo of a capacitor previous in the other videos which I discussed on AC and DC capacitor. I showed you the AC capacitor and DC capacitor. I also discussed some polarized and non-polarized capacitor. I show you all the images as well. So you can also go there and see how it look like. The dielectric can be made out of all sorts of insulating materials. These are where the dielectric can be made out of all sorts of insulating materials, which are what? Paper, glasses, rubber, ceramic, plastic, or anything that will impede the flow of current. So in that case, these are what the dielectric are made up of. These are the materials. The dielectric can be made up of all sorts of insulating material, which I have just mentioned: paper, glass, rubber, ceramic, plastic, and every other aspect of it. Thank you once again for watching my video. Please, if you like my video, subscribe to my channel, comment, and like. See you in the next class. And in the next class, we are going to discuss dielectric constant and every other important areas of dielectric. Thank you once again. See you in the next class.